This is section 2.2, part B, on multiplying polynomial expressions. In the first example, we're going to look at the product of a monomial and a polynomial, and this uses just the distributive property which we already know. So a monomial times a polynomial, I would distribute the monomial through, so 5x times 4x will give us 20x squared, plus 5x times 7 is going to give us 35x. The next one, it's also a monomial distributed through a binomial. 3t squared times 4t to the third is going to give us 12. T to the 2 plus 3 is 5, so t to the fifth. Minus 3t squared times 7t will be 21. 3 times 7 is 21. T to the third. Okay. Next, I have a monomial distributed through a trinomial. So again, once again, just distributing. So here I have 6 times 3 is 18. X to the 3 times x to the second is x to the fifth. Add those powers up. Minus 6 times 2 is 12. X to the 3 and one more makes 4. And last, 6 times 7 is 42. X cubed. Sorry, that one kind of faded into the D right there. I've got 18x to the fifth minus 12x to the fourth minus 42x cubed. And our distributive property for this last one here, negative times a positive makes a negative. 2 times 3 is 6. 1x, and then 2 more make x cubed, and y squared stays. Negative and a negative make positive. 2 times 5 is 10. 1x, 1 more, so x squared. 2y, 1 more, so y cubed. And last, negative and a positive make a negative. 2 times 1 is 2. 1x, no more, so just x. Y squared, 2 more, so y to the fourth. If I multiply two binomials instead of a monomial and a binomial, or a monomial and a polynomial, it's really just a matter of using the distributive law twice. So what I want to do is distribute everything in the first position, distribute x through binomial, and then distribute the second position through the binomial. So there are 4 things being multiplied here. So first, x times x is x squared, then x times 5 is 5x. Next, that finishes the first distribute. Now we distribute the 3. So if 3 times x is 3x, and 3 times 5 is 15. For our final answer, we'll combine any like terms. So we notice that we have like terms here in the center. So I end up with x squared plus 8x plus 15, adding those like terms up. So I have 2 binomials together. I want to distribute every part of the first binomial into the second binomial, then every part of the second term of the first binomial into the second binomial. Let's look at a few more like this. The next one, I'm going to distribute x to both x and 6. Then I'm going to distribute 4 to both x and 6. So that gives us x times x is x squared. X times 6 is 6x. Plus 4 times x is 4x. Plus 4 times 6 is 24. My final answer is going to have me combine any like terms. Once again, the only 2 like terms are in the center. So I have x squared plus 10x plus 24. In part B, the first term 2x, let's distribute it across, and the second term negative 5, we'll distribute that across. So 2x times 3x gives me 6x squared. 2x times 7y will give me 14xy. Negative 5y times 3x will give me negative 15. And you can either write that as yx or xy. I tend to keep xy so that all my variables are in alphabetical order. And finally, negative 5y times 7y will be negative 35y squared. Combine like terms. Most of the time, the 2 middle terms are going to be your like terms, especially if you have the same variables in both first and last positions in both of your binomials. So once again, I combine, I get 6x squared minus 14 minus 15 is negative 1, so just minus xy, that's negative 1xy, minus the 35y squared. There are a few more examples on the next page. So we're going to start with distributing the first term, so 4x times 4x. That gives us 4 times 4 is 16x squared, and then 4 times 7 will be plus 28x. The next piece, I've got negative 7 times 4, that's going to be negative 28x, and negative 7 times positive 7 is going to be negative 49. Combine your like terms. When I combine these like terms, my first term stays 16x squared. I've got a positive 28x and a minus 28x, so that adds to 0 x's in the middle. So I just move on to the next part, the minus 49. Okay. Let's look at a few variations. In the next one, the powers are different. So I've got a w squared in the first one, w in the second. Let's see how that works out. So first, 4w squared times 3w is going to be 12w cubed. Next, I'm going to have 4w squared times negative 5. It's going to be negative 20w squared. Next, 2 times 3w will be plus 6w. And 2 times negative 5 will be negative 10. This time, notice that you do not have any like terms, so my answer is already complete. In part C, there are 2 different types of distributes to do. I have a monomial to distribute and 2 binomials to distribute. I like to do my 2 binomials first, and once they're done, I'll distribute the 2 through the product. So I'm going to have 2 times, let's do the binomials. So 3x times 5x is 15x squared. Then 3x times negative 4y. 3 times 4 is 12, so that's going to be 12xy. Second half of the first binomials is going to be negative 2y times 5, so negative 10xy. Then 2 negatives to make this positive 8y squared. Okay. I'm going to combine my like terms before I distribute my 2 through. So I should have 2 times 15x squared, negative 12, negative 10 is negative 22xy, then plus 8y squared. Last, I need to distribute that 2, that monomial, through every single piece to finish. So we've got 2 times 15 is 30x squared, minus 2 times 22 is 44xy, plus 2 times 8 is 16y squared. Part D is similar to Part C. I have a monomial and 2 binomials to distribute. It's also similar to Part B because my binomials don't have the same power in each binomial. So I'm going to leave the 3x until the end. I'm going to go ahead and do the 2 binomial distributes. So first, x squared times 2x. It's going to be 2x to the third. Finish the x squared by doing x squared times 5. It's going to be 5x squared. Okay. Next, negative 2 times 2x is going to be negative 4x. And negative 2 times 5 is going to be negative 10. Okay. Similar to Part B, there are no like terms inside the parenthesis, so we're ready to finish by just doing the distribute of the 3x across all 4 terms. So 3x times 2x cubed will be 6x to the 4th. 3 times 5, the next one's going to be 15, x to the 3rd. 3 times 4, so it's going to be minus 12, x squared, and last, 3x times 10 will be negative 30x. Okay. In the next example, we're going to be multiplying some larger polynomials. So instead of multiplying 2 binomials together, I have a binomial times a trinomial, or 2 trinomials multiplied together. So first, binomial times trinomial, nothing much changes here. The 2x needs to be multiplied by all 3 terms in the trinomial. Then again, when we get to it, the negative 4 will be multiplied by all 3 terms. So first, 2x times x squared, that's 2x cubed. 2x times 5x, that's plus 10x squared. And 2x times negative 6 will be negative 12x. Then the first 2x term is finished. We're going to do our negative 4 times everything in the trinomial. So I'm going to have minus 4x squared. I'm running out of room, so I'm going to start writing underneath. Negative 4, positive 5 will be minus 20x. And last, negative, negative to make that positive 24. Okay. I do have like terms that I need to combine. I need to combine the 10x with the negative 4x. And I need to combine the negative 12x with the 20x, negative 20x. So my first term is going to be 2x cubed. For x squared, I'm going to have 10 minus 4, so 6. And for x, negative 12 and negative 20 is going to be negative 32. Last, the plus 24. Okay, so that's finished. The next one, we have 3 terms in the first parenthesis that we need to distribute all the way through the next one. So we're going to distribute a trinomial through a trinomial. Starting with the x squared, we need x squared times each term in the second parenthesis. So x squared times 3x squared is 3x to the 4th. X squared times negative 5x is going to be negative 5x cubed. X squared times negative 2 is negative 2x squared. Then we get on to the middle term. We have negative 2x times 3x squared. That's negative 6x cubed. 2 negatives is going to make this next term positive 10x squared. I'm out of room on this line, so I'm move to the next. Last, 2 negatives is going to make this positive 4x. Finally, I have to distribute the 4 across the trinomial. So we're going to have 4 times 3 is 12x squared. 4 times negative 5 is minus 20x, and 4 times negative 2 is negative 8. You need to combine all of these terms up. There's only one x to the 4th term, so I lead off with 3x to the 4th. For cubic terms, I have to combine negative 5x cubed and negative 6x cubed. So I have negative 11x cubed. For square terms, I have to combine 3 different terms. I have to combine negative 2x, 10x squared, and 12x squared. So if I add those up, for example, negative 2 plus 12 is 10, plus 10 more is going to be 20, x squared. And finally, the x terms, 4 and a negative 20 is going to be negative 16x, and last, the minus 8. Flip to the back side of this page to see a few more examples. Okay. When I write something like x plus y squared, we mean x plus y times itself. When I square something, I mean multiplying it by itself. So I mean x plus y times x plus y. If I'm going to simplify this, then I need to make sure that I do all 4 of the distributes. So x plus y times x plus y is, x times y is x squared. X times x is x squared, x times y is x to y, and then y times x, again, I could write it as yx or xy is the same thing, and last y times y is y squared. When your like terms combine, this gives you x squared. There's an xy here and an xy here, so plus 2xy plus y squared. Okay. So when I square a binomial, if it's x plus y squared, I need to write it as x plus y times x plus y, or if it's a minus instead, same thing. I need to write it as x minus y times x minus y so that I can multiply all the way out to get all 4 terms and then combine it back down to the 3 terms of my simplified solution. So a few examples like this. I have binomials squared. In the first one, we have x minus 4 squared. So that's x minus 4 times itself. So x minus 4 times x minus 4. And I want to multiply x times x is x squared. Then x times negative 4 is negative 4x. Negative 4 times x is also negative 4x. And negative 4 times 4 is positive 16. Combine the like terms in the middle to get x squared, negative 4, add to negative 8x plus 16. Let's look at a few more examples. Here I've got 3x plus 2 squared, so I need to multiply 3x plus 2 times 3x plus 2. And I'm going to follow the distributive property, multiplying 3x times 3x and 3x times 2. 3x times 3x would be 9x squared, plus 3x times 2 is 6x. Second half of the distributive, 2 times 3x is 6x, and 2 times 2 is 4. Add up your like terms in the center. It's going to give you 9x squared plus 12x plus 4. Part C. 2a plus 5b squared is 2a plus 5b times 2a plus 5b. We're going to get that distributive property down. 2a times 2a is 4a squared. 2a times 5b, that would be 10ab. 5b times 10a is also 10ba or ab. The order doesn't matter, but I like to write them the same way so I can see that they're like terms. And last, 5b times 5b is 25b squared. Combine your like terms in the center. It's going to give you 4a squared plus 20ab plus 25b squared. And the last one here just has an additional step. I have a binomial that I need to square, and then after I finish squaring it, I need to distribute a 3 through all of my terms. So this is the same thing as 3 times 5x squared minus 1 times 5x squared minus 1. I like to do my binomials first and deal with the 3 after we've finished. So I have 3 times 5x squared times 5x squared will be 25x to the 4th. 2 plus 2 is 4. Minus 5 times 1 is 5, x squared. Finish the binomial, distribute with negative 1 times 5 and negative 1 times 1. Negative 1 times 5x squared is minus 5x squared, and negative 1 times 1 is positive 1. So that gives us 3 times 25x to the 4th. Add up your like terms, minus 10x squared plus 1. Finally, I have one more distribute to do, a monomial to distribute this time. So just multiply 3 times 25 is 75, x to the 4th. 3 times 10 is 30, that's 30x squared, and 3 times 1 is 3. The bottom of the page, you have an opportunity to compare the properties for xy squared and x plus y squared. If you have a quantity x times y squared, you can distribute the power across the multiplication and it will give you just x squared y squared. I need to be careful that when I have x plus y squared, I cannot distribute a power across addition, only across multiplication or division. If I have a sum or a difference squared, I need to write the x plus y twice so that I can complete all 4 parts of the distribute. It's not appropriate to just square each term. I need to get 4 parts of the sum, not just the 2. Okay, so just comparing these, I can distribute an exponent across multiplication or division, but not across addition or subtraction. Moving on to the next page. This warning goes along with what we just said in the previous page. It's a common error to omit the middle terms when squaring a binomial. For example, it's a common error to just try to square both pieces to get x squared plus 36, and that is incorrect. The correct way to do it would be to write the x plus 6 twice, multiply it all the way out, getting the x squared plus 6x plus 6x plus 36, combining into the correct answer of x squared plus 12x plus 36. Okay. So again, it's a common error to forget to write the binomial twice and distribute it all the way out, but it needs to be done to get the right answer. Okay. On to a new type. Instead of squaring something, we're going to be looking at multiplying x plus 5 times x minus 5. I still distribute. So I have x times x and x times negative 5. So that's going to give me x squared minus 5x. And then if I multiply the positive 5, that's going to give me plus 5x minus 25. Add up your two center terms. So we've got x squared, negative 5 plus 5 adds to 0. So just the minus 25, the x piece went to 0. The next one, very similar. We've got 4x times 4x, which gives me 16. X squared, 4x times positive 3 gives me 12x. When I do the reverse, negative 3 times 4x gives me negative 12x, and negative 3 times positive 3 gives me negative 9. If I combine, I've got 16x squared plus 0x, so just minus 9. Now if you noticed, when you have two terms where they are the same two terms, the only difference is the sign in the middle, these are called binomial, because they're two terms, but binomial conjugates. When you multiply binomial conjugates, the middle two terms always add to 0, so your result's going to have just two terms instead of 3 or 4. So if you have something like x plus y times its binomial conjugate, x minus y, you will always get x squared minus xy, then plus xy, then minus y squared. You will always get your center two terms adding to 0. You'll always get a difference of x squared minus y squared. Okay, so we have a few examples that are binomial conjugates to work with. We're going to observe the pattern. We're going to just do the distributes. 5x times 5x is 25, x squared, plus 15x. Negative 3 times 5x will be minus 15x, and negative 3 times 3 will be minus 9. Observe that the center two terms add to 0 because they're binomial conjugates, and so you get 25x squared minus 9. The center two terms will never add to 0 unless you're multiplying binomial conjugates. Okay, in the last one, I'm going to have to do two different products. Let's do the first two together, and then once you get the result, we'll multiply it by the third binomial. So we're going to start with x times x is x squared. Then x times negative 2 is minus 2x. Then positive 2 times x plus 2x. Positive 2 times negative 2 is negative 4. Once we finish simplifying that, we're going to multiply it by x squared plus 4. So the first two are binomial conjugates, so the middle two terms add to 0. That gives me x squared minus 4 times x squared plus 4. Once again, I have binomial conjugates, so I should get the same pattern. So x squared times x squared gives me x to the 4th. X squared times 4 gives me plus 4x squared. Then negative 4 times x squared is negative 4x squared. And negative 4 times 4 is negative 16. Once again, the binomial conjugates mean that the center two terms add to 0, so I have x to the 4th minus 16. Flip to the back side of our page, and we're going to start part C.